Hello, my name is John Capobianco, and as you know, I've been working on a multi-agent system with a router agent, call it a parent agent, think of it as a root of a tree of other agents, and the main decision maker. This also acts as my front end in Streamlit, giving the user a natural language interface. So the user can ask questions or demand certain things be done, instruct it, prompt it. That main agent has been able to reach out to a few other sub-agents now. One for router 1, one for router 2, one for switch 1, one for switch 2, a NetBox agent, an email agent, now an image recognition agent. What I wanted to see if I could do was add agents for the Linux hosts. So we'll go back to the topology in a second, but there's two routers, two switches, and off of each of the switches, there's two Linux hosts. Now, two of these Linux hosts are running Alpine Linux, which I'm quite familiar with. The other ones are running some other lockdown version that I can't seem to affect, meaning I can't add routes or interface IPs. But the two Alpine Linux hosts, we can add default routes so they're reachable from the outside world, so our agents can talk to them. And we can add inside addresses so they can ping and become part of the topology within the network. So, can I write an AI agent to interact with the Linux hosts? Now, this would be really exciting to actually be able to drive a Linux operating system from an agent. And in this idea of infrastructure as agents, I've just added two agents, two Python scripts. They're less than 200 lines of code each. This agent is 150 lines of code. And if you took out my template, which is just the instruction set, it's probably like 50 lines of code. So, two new Python files, and then in my main agent, remember the parent and the root and the tree, I make it aware, hey, there's two new sub-agents that you can interact with that are for the PC1 and PC2 Linux hosts. All right, now the key to this is Cisco PyETS. Again, I've written the book on Cisco PyETS, and it is a key component. PyETS supports a certain subset of commands as parsers for Linux. So this was quite easily done, given I already had router and switch agents that I refactored to be more centric for the Linux environment. Let's take a look. All right, so again, this is the topology. We've got two routers, a switch, and these two PCs, PC1, PC2, available over this public address if you add the correct routing. They're also available internally if you set up this environment here. So, meaning from router 1, I can ping 10.10.10.200 and 10.10.30.200. From router 2, which if we ping from the sub interfaces across, you can see that I can reach both PC1 and PC2 from the two sub interfaces on router 2. Right, that's close enough to pinging the servers themselves. I wish I could get IPs on these servers, but anyway, that's as good as we can get. So, PyETS supports certain commands for Linux hosts. And some of them are pretty good. LSL, and a directory, IP route, ifconfig, and route, and a few other things. So what I tried first was how our PC1 interface is configured and what IP addresses do they have. And it came back with this response, which is correct if we look in the logs. So let me crank up the view and we'll take a look at the reasoning and the logic here. And it happens very fast comparatively to a router or a switch. So let me go back to the start of the chain of thought here. To determine the IP addresses of interfaces of PC1, I need to execute a command on PC1 that retrieves this information. The appropriate command to use on a Linux system is ip-addr show or ifconfig. So it does ip-addr show, and I'm not sure if that command ifconfig a here, and it gets back the observation. I've successfully obtained the network information using ifconfig a. Here's the relevant information. Finish chain. Now it looks like it does it again, successful. And it's going to try it again, right? And then back here, it does the chat completion and disconnects from PC1. So let's try to do this in real time. All right, and let's try to ping something, I guess. So if I go to PC1, can I ping 1010 30 200? Yes, I can. So I'm going to say, can PC1 1010 10 100 ping PC2 1010 30 200? Hi, I hate to break in at such an exciting moment, but let me just explain something. PyTS has .parse. Now those are the supported commands that we can run on a Linux host via PyTS to get JavaScript object notation back from the parsed command. Certain commands are supported, other commands are not, because there's no parser. PyTS also has a .execute and then an arbitrary command. So we can execute arbitrary commands. So I've adjusted the template, I've adjusted the agent a little bit to say, listen, if there's a parser, use the parser. If not, use .execute. And that's how we can get the ping to work, you'll see in a second, because I've given it the .execute capability and it can execute an arbitrary command like ping, even though there's no parser for ping. Just watch this. Okay, so we're going to say, can PC1 ping PC2 and can PC2 ping PC1? Now I'm specifying the IPs because I don't have a DNS system set up. Otherwise it would fall back to DNS. Let's not worry about that. We're just going to give it the IPs. Hitting send. So now let's watch the reasoning in action here. And it should call, right, to determine if PC1 can ping PC2 and if PC2 can ping PC1. I need to attempt pinging each PC from the other. Right, so it's going to try to ping with 4 packets from PC1. So it's logged into PC1. It realizes there's no parser, so it falls back to .execute. We can see the 4 pings were executed from PC1 to PC2. The ping command was successfully executed on PC1 with connectivity confirmed, all 4 packets transmitted with an average round trip. So now it's going to move on to PC2 and run the ping on PC2. It's even giving us the average round trip amongst all 4 packets here. So now we're going to get it. We should have our answer back. Yes, PC1 can ping PC2 and PC2 can ping PC1 successfully. Let's try this again with, could you please include a report of the round trip averages and compare them. Send. So the sort of the same command. We're going to get the pings, but hopefully we can get a little bit more out of the knowledge and actually do like a comparison and see what information we can get back. So it's already en route on PC1, pinging PC2. and collect the round trip average times. A little bit different, right? So now it's going to connect to PC2 and run its pings from PC2. And hopefully we should get back an analysis. I didn't mean to open that. Hang on. Average round trip from PC1 to PC2 is 1.273 milliseconds, while from PC2 to PC1 it's 1.12 milliseconds. PC2 to PC1 has a slightly faster average round trip time. Okay, let's try something like this. Can you please use sudo and create a file called created by AI agent.txt with the contents hello world from the first AI agent for Linux on PC1. Send. Now just to show you over here, ls and ls slash, I don't have any files over here. So it's already done the reasoning and the command, and let's see if it actually worked here. So it did try to echo out that command in sudo t / created by AI agent.txt. Hello from the world's first AI agent, disconnecting. Now it thinks it's created it successfully. So if I do a cat, yes, yes! Hello from the world's first AI agent for Linux. From a command line using an agent, I've just created a file. Let's change this to PC2 and do the exact same thing. If I go over to PC2 and do an ls, there's nothing here. PC1, there's the file. So let's go back to the reasoning. It's already done. It should be done, by the way. So if I do a cat, there it is again. Hello from the second AI agent for Linux. Pretty cool. Well, now what else can we do? I'm going to pause the video here and try something. Well, now let's just try it live. Let's just try it live. But this might be a cut point. Now let's try this. Do I have Python on these PCs? Yes, I do. 3.11.6. So let's try this. Let's try this. Can you please use sudo and write a hello world Python script on PC1 and run it to confirm it works? Let's see this. Let's see if we can get it to write a Python script on PC1 for hello world and see if we can run that Python script to say hello world or whatever. So it looks like it made the hello world file with print hello world. Now is it going to log in a second time and run it to prove that it works? Yes, it is. Here we go, log in the second time. And I'm going to copy the exact same command and run it on PC1. Hello world. Hello world. Hello world. Can you please create a Python script and run it to make sure it works on PC1? Creates the Python script, runs it to validate that it works. And we ran it manually to make sure that it works. So an AI agent for Linux that can run ping commands and can create files and can create even Python scripts and run Python scripts. All from natural language, all from 150 lines of code. If you're interested, and I'm going to do this at the end on purpose, if you've stuck around, let's take a look at the Python on how this was written. So we have PC1 and PC2 agent. The code is the same. I just have two different files so we can invoke them differently. We have our imports, which include operating system JSON logging. From PyATS, I need the topology loader. From LangChain, I'm incorporating 4 different things. I'm bringing in their tools for tool calling, prompts for the prompt template, agents for the agent executor and to create the React agent, and OpenAI to call the LLM. I'm using .env to load up my OpenAI key and setting up some basic logging. I do provide it the supported PyATS commands for parsing to JSON. Those commands are special in that they have parsers. But then I have this main function, run Linux command. I load the testbed, I connect to the device, and then I handle certain pipes because pipes and redirects aren't supported by PyATS. We either parse or execute the command in Linux. I have a couple of Linux tools that are decorated as that tool. The Run Linux command tool and the Execute Linux command tool. I define my LLM and my temperature and my model. I set my list of tools. I set my list of tool descriptions. I have a template here that is about 30 lines of code for template. The key here is the format of thought. Do I need to use a tool? Action. Yes, you should use one of these tools. Action input, the input to the action, the result of the action, and then the final observation to the user with a few different examples. Begin, chat history, new input, and the scratchpad. I have my input variables, which are input, scratchpad, and chat history, my prompt template, my agent, where I create the React agent using the LLM, the tools, and the prompt template, and then my agent executor, where I have a max iterations of 50, I have verbosity is true and error handling is true. And then I have my handle command to handle the actual output. In the main agent, I've imported the tools as PC1 agent and PC2 agent. I've initialized my agent as zero-shot React descriptions. I've set up my functions for my agents. I've listed them as tools. I've added them to the master tools. And that's it. Now the main agent has access. And I'm going to save that.